Alright everybody, today let's talk a little bit about rational functions, multiplication and division with them, and some simplification. So the first thing we're going to do is start off by doing the first example, where we have 30m and 3, 40m squared n. So whenever you see n to the 3 or m to the 2, remember that that's equal to n times n times n, or m times m. So because we have 3 n's and 1 n, we can cancel that. And because we have an m and an m squared, we can cancel that to become m to the 1 and cancel it on the top. And then because we have 30 and 40, we can simplify that. So this should just give us 3 over 4. The m's are gone. N squared over m. Okay, let's try the next one. So in this one, you'll notice that the numerator can be simplified by factoring out a 2 and an x. So if you take out a 2x, you'll be left with x minus 2 all over 2x. So the 2x's can cancel out, and you're left with just x minus 2. If you're asked to find the non-permissible values for these sorts of questions, what you need to do is figure out anything that would make the denominator equal to 0, because when you have 0 on the denominator, then that means it's undefined, and that is not possible. So in this case, m cannot equal 0 and n cannot equal 0. In this case, x cannot equal 0. So here, m, n belong to all real numbers, and here x belongs to all real numbers as well. Okay, now let's try doing this one. So we have a quadratic, so the first thing you should do whenever you see a quadratic function is to factor it down. My personal method is to always use guess and check. So for the first one, I would say, okay, what two numbers multiply to get to 15, but also add to minus 8? Okay, so that seems like good options would be factors of 15 are 5 and 3, or 1 and 15. So I'm going to try doing minus 5 and minus 3. So when I do that, x minus 5, x minus 3, all over x minus 3, then that means that's good, because if I check this, I would go the outermost times the outermost, which would be minus 3x, and then the innermost times the innermost, which would be minus 5x. So once those are added together or subtracted, basically you'd get minus 8x, which is how you know that you factored it correctly. So now that we checked that, we can cancel x minus 3, and we're just left with x minus 5 as our answer. And as far as something that would make this undefined, we cannot have x or the denominator equal to 0, so we would just move it over and say that x cannot equal to 3, and then x belongs to all real numbers. Okay, try the next one as well, but here we're going to take the same steps. Realize that 9 minus x squared is like a difference of squares basically, so that can be broken down to 3 plus x and 3 minus x. And then on the numerator, I'm again going to use guess and check. So since here we have 2x squared, the first thing I'm going to do is write a 2x and then an x, and then find two numbers that would multiply to get to minus 3. So I'm going to guess and check my way to that. I'm going to start by putting, say, minus 3 there, plus 1 there. Let's see if this works. 2x times minus 3, so outermost times outermost would be minus 6x. And then innermost times innermost would be plus x. So that does indeed work, because when you add that together, you get negative 5x, which is the middle term. So now that we have that, we can see that we have an x minus 3 on the numerator and the and 3 minus x on the denominator. So if I rewrite this second fraction, so I'm just going to move it down here, 2x plus 1, x minus 3 over, if I factor out, let's see what happens. So if I go x, negative x, yeah, so that's not going to work. Let's leave the first one, 3 plus x. But in the second one, let's rewrite it to be a negative on the outside, and then x minus 3. So now, x minus 3 can cancel, and you're left with 2x plus 1 over 3 plus x, and there's a negative that's out front, so that can just be put up there. And then as far as our non-permissible values, we would set negative x squared cannot equal to 9. So if you move this over, and then try to take the square root of negative 9, that's not possible. So in this case, x belongs to all real numbers. Great. All right, now let's continue multiplying and dividing with the rational functions. So this first example here, relatively okay. 10 and 5 can be canceled out into 1 on the top, 2 on the bottom. A squared, a can be canceled, so we'll be left with 5AD all over 4. Good. And then now in this one, 3 and 9 can be simplified to 1 over 3. We have 4 and 12 can be simplified to 3, 1. And then 6 can be broken down into, we can take out like a 3, so 2, 5, and now just combine everything. So we'll have the a squared from there times by 2a all over 3b3 multiplied by 3b multiplied by 5c, which can just be condensed into 5a, or 2a to the 3, 9b to the 4, and then 5c, which is just 45. Nice. All right, now let's try some of these. So the first one, I'm just going to create a bit more space. Move this down. First thing I'm going to do is factor everything. So it'd be x plus 4, x plus 1. And then this can be, you can take out a 4 and have it be x minus 2. This is x plus 1, x minus 1. And then the bottom one, I can factor out a 2 first and have it be x squared minus 4x plus 4. And that can be broken down to be x minus 2 squared. And I'm just going to replace this with that. So now, I can cancel this and this. X plus 1, and I would be left with the 2 can become 2, and this would just become 2 times x plus 4 over x minus 2 times x minus 1. Good. All right, now let's do some division ones. So division, same strategy as before. You can just multiply by the reciprocal. So if you take out a 2, it would be like that, y plus 2 And then this is the same thing as multiplying by y squared minus y minus 6 over y squared minus 4 is the difference of squares, so that's just y plus 2, y minus 2. And then this y squared minus y minus 3, this can be factored down to y minus 3, y plus 2. So I'm just going to replace it. I highly recommend, if you're having trouble with factoring, practice that, because that's a super important skill for math in pre-calc 11 as well as 12 as well as calculus. So now that I did all of that, this would become 2 times y minus 3 all over y plus 2. Nice. Last one. So this is 4x minus 10 over x plus 3 all over this thing. So remember, that just looks intimidating, but you can just treat it as a division symbol. So you can treat this like factor out of 2, be 2x minus 5 over x plus 3 divided by 12x squared minus 60 plus 75. So that's all over 2x. So I'm just going to take out the 2. And it'd be x squared minus 9. So now this is a difference of squares. So we can condense it and make this like cancel out the 2's. And then we'll factor the 12x squared minus 60x plus 75 as well. So what we will do is we'll go 2x minus 5 over x plus 3 multiplied by x plus 3, x minus 3 for that denominator, the x squared minus 9. And then we will factor out a 3 from that, and it will become 4x squared minus 20 plus 25. And then now this is basically pretty factorable, because we can have 2x minus 5 squared, and that's equivalent to that. So I'm just going to replace it. So now I can cancel 2x minus 5, one of them, and x plus 3, and then my final answer will be left with x minus 3 all over 3 times 2x minus 5. Perfect. So yeah, I hope that is helpful. Keep practicing, factor everything, simplify, get really good at like factoring things down quickly like I showed in the beginning. Use 2 brackets, guess and check. And yeah, take care.